So on the one hand, we've all heard about the data deluge, data being generated from systems of record, transactional systems, from people interacting with their smartphones, and of course now with the Internet of Things, data being generated by machines. All this data needs to be processed somehow. On the other hand, we've seen that Moore's law is starting to hit an end. We've hit an end of Dennard scaling, that is to say that the energy per transistor is not decreasing anymore. So this results in the fact that the expected cost, the decreasing cost of hardware to treat this data is no longer going to keep up. So we need to do something architecturally, and the machine is an architecture to try and address this problem. In terms of application, the first application we're looking at is for doing data analytics, that is doing big data processing for machine learning, unsupervised learning, and then classification and that sort of thing. The major benefit of non-volatile memory is that when it's not being used, it's not consuming energy, as in comparison with dynamic RAM, which needs to be refreshed because the charge leaks out of the trench capacitors. The other is that it allows us to obviate the need for secondary storage, in the sense that when we need to bring data from disk into memory and move the data back out to disk, this is consuming energy. So the main benefit is energy saving. Yes, the reason why it was called the machine is because it wasn't a server, it wasn't a PC, it wasn't a smartphone, it wasn't a device. So the architecture is really able to be applied in lots of different domains. So specifically in the Internet of Things, smart sensors, the combination of non-volatile memory and low energy microprocessors is going to be beneficial, and then the same programming models that we're going to be using in the bigger machines are still applicable in the embedded space.